Now you should have looked at the discussion board to see if your answers for 2 and 3 are correct by now. And I want to go through number 4 because that asks us to do things in a little bit different way. You are now supposed to draw the divided rectangle, and you want the divided rectangle to illustrate the product of 4 and the sum of 2x and 3y. So I'm going to start by drawing my rectangle. We want to divide our rectangle somewhere, and notice that the sum is 2 terms, 2x and 3y, so I just need 2 areas. You could divide it anywhere you wanted. So if we're going to add 2x and 3y, we want to put those along the length. And they want the product of 4 times that sum, so you want the 4 on the outside. So that's a divided rectangle that will tell us what 4 times the sum of 2x and 3y should be. And that looks like they say rewrite the product as a sum. So we know to rewrite the product of the sum, one of the things we can do is work out each of these regions separately. So when I'm looking at this first region, I can find that area by saying that's 4 times 2x. And I can figure out the region of this other smaller rectangle by taking 4 times 3y. And then if I add those two together, I'll get the area that's represented by 4 times that whole length. So now I need to go back in and simplify those terms. I'm going to go back and do one thing first. If you remember, early this quarter, we identified terms as being separated by addition and subtraction, not in grouping symbols. And we're going to still concentrate on that by simplifying each of these terms before we try and do any adding when we're working in algebra. 4 times 2x simplifies down to 8x. 4 times 3y simplifies down to 12y. We should try and add these together, but 8x and 12y are not like terms, so we are done with that expression. So we have that our 4 times 2x plus 3y is equal to 8x plus 12y. Now I'm not finished with number 4 yet because the last sentence says to verify your result by numerical substitution. So I need to substitute some numbers in for x and y. I'll change my pen so you know I'm doing something different now. So I'm going to let x equal 5 and y equal 6. Then the original expression looked like 4 parentheses 2 times x, I'm going to change that to 2 times 5, plus 3 times y. And my answer was 8 times x plus 12 times y. So there's my numerical substitution. Now let's see if this actually works. So for the first one I have 112. We'll try the second expression. In the second expression, I have 112. Because these two are equal, I know that this answer checks. Okay, let's go on and look at number 5 on the activities. So we'll clear this out. And I think I'll clear my calculator while I'm at it. So number 5 says to write an expression for the area of the following figure by adding the lengths on the long side and then multiplying the length and the width. So this is very much like what you were doing before. Part A, we want to find the area by adding the lengths of the long side and then multiplying the length of the width. So we want to multiply the A times and add the lengths of the long side. Part B, write an expression for the area of the following figure by determining the areas of regions 1 and 2. And then adding the results. So the region for number 1 is A times B. The region for 2 is A times C. And if we want the whole rectangle, we would add those two results. So it's A times B plus A times C. And then describe a rule. Well, the rule is your answer from Part A is equal to your answer from Part B. What we've done is we've written the basic rule for the distributive property Those of you who have had algebra in the past may have stopped by saying it's the distributive property, but it's really more precise than that. It's the distributive property of multiplication over addition. And as we move away from our rectangle figures, we can not only do addition, we could do subtraction as well. So let's take a look at why they call this multiplication over addition or subtraction. So the multiplication is right here. It's A times something. And to get to this answer down here, we distribute the A over the addition by multiplying the A times each of the terms inside of this parentheses. So we think of this as multiplication over addition. And so we're going to move next to some abstract problems where we're not going to have the picture, but we'll use that idea of multiplying each region to get to the final answer.